Hey everybody, welcome to our webinar tonight. Tonight's topic is going to be exponents, polynomials, and factoring. So let's get started with that. So first let's go over what exponents are. So exponents is a method of writing repeated multiplication with a base. So for example, here we have 30 to the 5th power. This is the same as writing 30 times 30 times 30 times 30 times 30. You multiply 30 by itself 5 times. But instead of writing it out in the very long way, such as writing 30 times 30 times 30 times 30 times 30, you can just simply write it with the base, which is 30, and with the exponent, which is the 5. So how will we write this as an expanded multiplication? So we went over this previously. It would be 30 times 30 times 30 times 30 times 30. So basically, exponents is just a quicker way of writing it, and it's kind of like a connotation of a sort of connotation that's like a quick-hand way of writing it. So now we have an example. Evaluate the following: 5x cubed if x is equal to 5. So the first step of this is to plug x into the equation. So we have 5. And then now we're going to plug in 5 to wherever we see x, and we are going to cube that. So first, let's solve this right here, 5 cubed. So as we mentioned previously, in this area right here, 5 is the base and 3 is the exponent. So this would be the same as writing 5 times 5 times 5. And don't forget about this 5 right here, which comes from over here. If we pull this down, we get 4 5. This is also equal to 5 to the 4th power. And then we can further evaluate that to get our answer, which is going to be 625. So 625. And this is our answer. Next, we will be talking about exponent multiplication. So when there's a common base that are being multiplied by each other, you can combine them together to simplify. So as we mentioned earlier, the base is a number that is, or I would like to think of it as the bigger number, so the one that's not floating up in the air. So in this example right here, the base would be a. And if you notice that in both of these sets of parentheses, they both have a as the base. So now there's a rule that says that when the bases are the same, you can just add the exponents together. So this can be rewritten as a to the power of 3 plus 10. And when we solve 3 plus 10, which is equal to 13, this can be rewritten as a to the 13th power, which is your answer. Next, in this, we see that there is also a common base, but this may be a little bit more trickier to look at first. So we see that there's a 5 and a 6, but we should also pay attention that it's actually 5a squared and 6a to the 9th power. So first, instead of rewriting the base the same way so that it's a, we're actually going to multiply the 5 and the 6 together this time. So then we would get 30 a to the 2 plus 9th power. And when we add these together, we get 11. So then this whole thing can be rewritten as 30a to the 11th power. Next, we'll go over exponent division. So when there's a common base that are being divided by each other, you can combine them together to simplify. So x to the 3rd in this example example is being divided by x to the 10th. So we can rewrite this so it's easier to look at with x to the 3rd on top and x to the 10th on the bottom. Now in the previous example, in these, we added the exponents because we are doing multiplication. However, now we're going to subtract since we're doing division. So now we can do x to the 3 minus 10. And when we do 3 minus 10 right here, we'll get negative 7. So our answer is going to be x to the negative 7th power. And this can also be rewritten as 1 over x to the 7th power. So these two are equivalent to each other, and they're both the correct answer. In this example down here, I'm going to change to pink now. First, we're going to rewrite it with 5 to the 8th power on top and 5 to the 5th power on the bottom. Now, the tricky thing about this is that we're not going to do 5 divided by 5. Instead, we're going to keep the base the same, so it's still going to be 5. It's going to be 8 minus 5. And when we do 8 minus 5, we get 3. So now we have 5 to the 3rd power, which can be further simplified when you do 5 times 5 times 5 to 125. And both of these answers are correct. So now we have an example. So evaluate the following problem. 12x cubed divided by 3x. So first, let's rewrite this so that the big number is on top and the second number is on the bottom. 12x cubed divided by 3x. So now we see that the bases are not the same. So in this case, we can divide 12 by 3 first. So Kyle, would you like to try and solve this problem? Sorry, we didn't acknowledge you previously, but would you like to try work on this problem now, since we did the other problems? Okay. Are you familiar with how to use Blackboard? I know you weren't here when we went over all the different functions of Blackboard. So let me know if you need any clarification of how to use the different tools. So I'll give you 2 minutes to solve this problem. You got the x squared part right, but right here, we're going to do actual division on this instead of subtracting. So this was correct. Would you like to try again? Yes. So 4x squared. So since the variables since the exponents are most closely attached to the x right there, the x's are the same base, so you can still retain subtracting the exponent 3 minus 1, there's an invisible 1 right here, to get x squared. But since these are just regular whole numbers, we can just go ahead and divide them out. Does that make sense? Or do you need me to further clarify it or give any more examples? Okay. Do you want me to write another example, like make one up on the spot for you to try again, or are you okay with moving forward? Okay, that sounds great. Okay, so now we're going to talk about single variable polynomials. So first, let's go over the definition of what a polynomial is. So polynomials are classified by their degrees, where it is the highest term. So it is arranged from the highest degree to the lowest degree. So basically what this is saying in more basic terms is that the exponents are arranged from like biggest to smallest. So you can see here the 3, and there's the 2, and then there's an invisible 1 right here. And then when we get to the 4, there's no x variable and no exponent, so that's the last one. And when we classify them by their degrees, we always look at the highest term. So in this example right here, what is the degree of the polynomial? You want to give it a shot, Kyle? Yep, that's perfect. So 3, since right here it's the greatest degree. So in algebra, it is also very common to evaluate polynomials. So if we take this problem, evaluate 3x squared minus 2x squared plus 2, if x equals 2, first we can clump together terms that are similar to one another. So you see here we have 3x squared minus 2x squared. So this can be reduced, and then we can bring this down. So Kyle, do you know what we would get if we were to reduce this expression right here? Without looking at the x equals 2 part. So just simplifying the expression and making it kind of more condensed. Not quite. So you would actually get 1x squared plus 2, because 3x squared minus 2x squared is equal to 1x squared. So in this example, we would consider the variable to be the entire x squared. And you retain that when you do the subtraction instead of eliminating it altogether. So because it's a variable, you would keep it in the expression. Does that make sense? Or I can explain it a different way if you would like. Okay. So awesome. So now we have our expression that's more condensed. It's x squared plus 2. But we're not done yet. So it says if x equals 2. So now whenever we see an x in this expression right here, we're going to plug in 2. So now we can rewrite this as 2 squared plus 2. And would you like to give the final answer, Kyle? So let's break it down step by step. So let me change my color pen first to orange. So first we're going to talk about PEMDAS, which is order of operations. So this helps us to decide what to do first. So PEMDAS stands for parentheses, which is right here. That's the P. Parentheses, exponents, multiplication, division, addition, and subtraction. So that's the order that we want to go in whenever we try to solve an expression or an equation. So first, parentheses, right here. And then we also have exponents, which is right here. So 2 squared. Do you know what 2 squared is equal to, Kyle? It's the same as 2 times 2. Perfect. So we have 4, and we're going to bring this part down. So 4 plus 2 equals 6. And this is our answer. Does that make better sense now? Or do you understand it a little bit better? Okay. Feel free to ask any clarifying questions or whatever questions you may have too. Okay. On to the next slide now. Now we'll talk about simplifying polynomials. So when you are tasked with adding and subtracting polynomials, you use the same method as combining like terms. So again, what this is saying is that when you're adding different variables to one another, you want to clump the terms that are similar together and then perform the operation on those terms first. So in this example, we have 3a plus 3 plus parentheses 2a plus 7. So we see that here we have 3a and here we have 2a. So since both of these numbers are attached to the variable a, we can kind of pull it out and rewrite them like this, since they're similar terms, like terms. So 3a plus 2a, and plus, and then our other similar terms are 3 and 7. So those are just regular whole numbers, so they can be added normally to one another. 3 plus 7. And now we're going to do these operations separately because they're different variables in a sort of way. So 3a plus 2a, we can do this one first. So do you know what this would give us, Kyle? Yes, perfect. Good job, awesome. And then next, we just do 3 plus 7. And what would that give us? Perfect. And what sign goes in the middle, right here? A plus or a minus, perfect. So our answer is 5a plus 10. Great job. And here's another example. So would you like to work on this one yourself, Kyle? It's a little bit more complicated, but only because there's an extra, they threw in something extra in there. So I'll give you maybe 3 minutes to do it, and feel free to ask any questions. Okay, so your final answer is 10x squared minus 2x plus 1. And that looks great. So that is the right answer. So I'll just write it on the board right now. 10x squared minus 2x plus 1. Awesome job, Kyle. Okay, so what you did was you combined these two terms, right, because they have the same x squared variable, and then these two terms since they only have the x, and lastly, these whole numbers since there's no variable attached to them. Great job. Okay, so onward to our next example. Would you like to try this one out too? I would like to warn you beforehand that there is a negative sign that does require like distributing. So go ahead and give that a shot. Hi, Kyle. Yes, that is the right answer. Great job. You're really good at this. So we have 15x squared here, and then negative 9x squared. So 15x squared minus 9x squared will give us 6x squared, which is what you got. Awesome job. And then we have 12x minus 10x, which would give us positive 2x. And lastly, we have 20 minus 5, which is positive 15. Awesome job. Onward. Okay, so we're going to start a slightly new topic now. It's the greatest common factor. And before we get started, let's go over the definition of what a factor is. So based on this PowerPoint slide we have right here, factors are the building blocks of multiplication because they're the numbers that you can multiply together to produce another number. And polynomials can be written as a product. So factoring is very similar to the process of prime factorization. So basically what all this is saying is that when there's a number, for example, if you have 18 right here, there are different numbers that can be multiplied together to make up 18. So for example, 1 times 18, 2 times 9, and 3 times 6. So all of these different numbers right here, 1, 18, 2, 9, 3, and 6, are all considered factors of 18. So right here it asks you, what are the factors of 20? Would you like to give that a go, Kyle? We can also go over different examples if you'd like to. perfect. So you got all the different numbers that are able to be multiplied in order to get 20. So the factors would be 1. I'm just going to list them from biggest to smallest. Smallest to biggest. 1, 2, 4, 5, 10, and 20. And something cool is that if you draw a rainbow, when you multiply these numbers together, the product always comes out to 20. So, good job. And next, we have the greatest common factor to factor polynomials. So, it asks us, what are the common factors? So, in this chart, we are given different polynomial expressions, and it breaks down the different terms that are in this expression. So, I'll just number these right now, 1, 2, and 3. So let's look at this first example right here. We have 6x plus 9. This polynomial expression can actually be further simplified by factoring out a common factor that is both in 6x and in 9. So I think the first step that would be good is to list the factors in 6 and the factors in 9. Do you want to give that a go, Kyle? So common factors. Very similar to what we did in the last problem. Awesome job. That's perfect. So for 6, we have 1, 2, 3, and 6. And for 9, we have 1, 3, and 9. Do you see any number that is a common factor for both of these numbers? Yes. So that means that we can factor out, which is basically the same as dividing, 3 out of this polynomial expression. So if we have 6x plus 9, and we take out a 3, and we put an empty parenthesis set in here, do you know what would go in this blank and in this blank? You are very, very close. Remember that there is an X right here. Do you want to try it again? You're super close. This is 3 for sure. Yes. Perfect. Yay! Awesome job. So this would be the expression for 6x plus 9. Do you want to try number 2 by yourself and tell me what you get? This time I'm going to give you a hint. You're going to be factoring out a variable. Okay. Let me know if you get stuck or need help or have any questions too. Not quite, but you're on the right track. So this is a little bit trickier. So we have a squared, which is the same as a times a, and that's pretty much all that we can multiply for a squared to get a squared. And then the next term that we have is negative 2a, or just 2a. And to get this, you can multiply basically just a and 2, right? So do you see any common variables or numbers that are in both of these factors? Yes. It's a little bit different than what we're normally used to, which is factoring out a number, but you can also factor out variables that both terms have in common. So we have a and a minus sign. So what would go in these two blanks? So when you factor out a term, you're basically going to divide both expressions by this term that you just factored out in order to get what's inside the parentheses. So if we divide a squared by a, we're going to get a. And if we divide 2a by a, what do we get? So 2a divided by a. Yes, correct, 2. So our answer would be a parentheses a minus 2, then close parentheses. Does that make sense, Kyle? Okay, let me know if you want me to clarify anything or go slower or have any questions. And then last one, would you like to try this on your own as well? I'll give you a hint for it first. You're going to factor out both a variable and a number. Variable and a number. Perfect. So that's the factor that you're going to pull out of the expression for C. And now what will go inside the parentheses right here? So there's going to be something right here and right here. And remember, you're going to divide each term in the expression by 4C. Yeah, that's perfect. Oh wait, 4C squared and 1. Okay, you're very close. Sorry. So we have this first term right here. We have 4C cubed, and we're dividing it by 4C. So we're actually just going to get C squared because 4 divided by 4 is equal to 1. So in here we'll have C squared plus 1. Does that make sense? Okay, awesome. So great job with doing these 3 different problems. And let's move forward to a different one. Okay, so example, factor 81c cubed d plus 45c squared d squared. Now this looks a little complicated, but we're going to take it one step at a time. So I want you to try this, but I want you to look at these 2 terms and see what the common factors are for those. And then look at these 2 terms and see what you can pull from these. And lastly, these 2. Give it a go and check back in. You can just let me know if you get stuck or have any questions or need help. Hi, Kyle. Yes, that is perfect. I'm so proud of you. Okay, so we have 9c squared and d. Now what will go in here? So remember that when we want to find the terms that are inside the parentheses, we're going to divide each of these terms. So the 81c cubed d and the 45c squared d squared by the factor that we pulled out. So let's look at them separately. So we have first 81c cubed d, and let's divide that by a factor, 9c squared d. Now we're going to group like terms together. So we have 81 and 9, c cubed and c squared, and then d. So 81 divided by 9 is just 9. And then the rule of division for exponents tells us to do c cubed minus 2. So c to the 3 minus 2, 3 minus 2. And then d divided by itself is just 1. So that gives us 9c, which we can plug right here. And then we do the same thing for our second term. 45c squared d squared divided by 9 c squared d. And we group together these terms. C squared divided by c squared is just 1, so this cancels out. 45 divided by 9 is 5, and then we have d to the 2 minus 1, which just gives us 5d. Does this make sense, Kyle? So you always want to divide each of your terms in the parentheses by the factor that you pull out right here in the front. Okay, awesome. Is it okay to continue forward now, or do you have any questions or need any clarification? Okay. Yay. Okay. Now do you want to try this one on your own, or do you want me to kind of break it down first a little bit? Okay. This one is a little bit trickier too. I think with each slide that we go forward, it gets a little bit trickier. So for this one, you're going to do 2 sets of parentheses, which is very different, pretty different from what we've done previously in the other slides. So let's look at this set first, these 2 terms, and these 2 terms. And our answer is going to look something like this. And this is going to be from here. This is going to be from here. Do you want to try it now, or do you want me to continue explaining? Okay, awesome. Okay, I'll give you some time to try it out. Kyle, good job. You're very, very close. So for this first expression right here, you can also pull out an A. So it'll be 4A here, then you would get B plus 3. And then for the second part, you're right in pulling out the 3, but 3B, which is the first term, divided by 3 would give you B, which would go here. So you would get B plus 3. And now, since these two terms are similar, we can do something weird with this. Are you ready? So, we can actually rewrite this whole thing as 4A plus 3 B. Oh, wait, I'm sorry, you cannot do that. Wait, this would be your final answer. Does that make sense, Kyle? Okay, I'm thinking of multiplication. This is different. Okay, so let's go on to our next slide. Okay, this is a little bit different as well. It's going to be factoring trinomials. So now we have three different terms in this expression. And our answer looks something in the form of this. And what we want to do is we want to have these two terms equal the first term when we multiply them together. And then we want the multiplication product for these two terms, the green, to add up to each other when multiplied. And then lastly, we want these two terms to equal 10 when we multiply it together. So what two variables when multiplied together will give us x squared? Perfect. X and x. So that's the easier part. Now we want to find two numbers. It's kind of a puzzle that when multiplied together, so multiply, will give you 10. But when you add it together, will give you 7. So can you think of any two numbers that fit this criteria? Perfect. So you can put it x plus 5 first or x plus 2 first, but basically this is going to be your answer. Does that make sense? And this is different from the other problem because this is multiplication. Okay. So this kind of just goes over what I just last explained to you. So we have the x squared right here, and then we want to have two numbers that when added together. So example, rx plus xfx to equal this. So when they're added together, we want them to equal this number when we multiply them together. So those are the rules on factoring. So first, we want the two terms. Let me just terms to equal x squared. And then we want our two numbers that equal c when added together. And we want those same two numbers to equal c when multiplied together. So these are the steps on factoring. And usually it's going to be in this format. to some power, and then a sign. It can be plus or minus a number, and then x to some power can be either plus or minus some number. And that's basically the steps on factoring. Does that make sense? Or do you have any questions? I know it can be confusing at first. Okay, awesome. We have another example coming up, so you can also practice. Okay, and here it is. So 3x cubed minus 3x squared minus 90x. But I'm going to give you a hint on how to solve this problem first. So you're going to want to, before you even start factoring anything from this problem, you're going to want to pull out a number and a variable. So what would you pull out here? Perfect. So 3x. Now what terms would go in these blanks right here? You're very close. So you want to look at each term individually and divide by the thing that you pulled out. So first we have 3x cubed, and we want to divide that by 3x, which would give us, and then we want to do 3x squared divided by 3x, which would give us, and lastly 90x divided by 3x equals. So what would you get now based on this? Perfect. So we have x squared, x, and 30. Now that we have this, we can focus purely on all the equations and all the variables and numbers in this set of parentheses. So remember how we did factoring like this over here? We can also do that to this set of parentheses now. So we're going to have x, it might be a plus or a minus a number, times x plus or minus a number. So what two numbers when multiplied would give us negative 30, and then when added together would give us negative 1. There's an imaginary 1 in front of this. Keep in mind that you can also use positive and negative numbers. So think of all the factors of 30. I think that'll help you. So I'll type it in the chat box. Perfect. Okay, so we're gonna get, it doesn't matter what order you put it in this time. So you're gonna get x minus 6x plus 5. And don't forget the 3x from right here. That'll just be right here in front. So this is your final answer. Great job, Kyle. And then this is gonna be our last example for tonight. So this is a little bit different because now we have a 6 right in front of the z. So if you remember earlier, I was mentioning doing this kind of rainbow thing, like this. So now what we're looking for is two numbers for this that will equal 6 when multiplied to 6z squared when multiplied together. So 6z squared when multiplied together. But you also want those two numbers must equal 11z when added to two different numbers from the factors of 4, and the factors of 4, and then the factors of 4 must equal 4 when multiplied together. So it's a bit tricky. And there's nothing that we can pull out from this expression. Do you want me to walk you through this one? This one's a pretty tough one. Okay. So first, how I would approach this problem is first I would think of the factors of 6. So there's 1, 2, 3, and 6. And then I would think of the factors of 4. 1, 2, and 4. And I'm going to look at these different sets of factors and see what numbers I can mix and match to get 11z when added together. So I think I'm going to use 2z over here and 3z. These are going to be both plus signs. And I'm going to do 1 and 4. Yes. So you see that when we do the rainbow, 2z times 3z gives us 6z squared. And then we get 2z times 4 is 8z. We add that to 1 times 3z, which is 3z, to give us 11z, which is the term we want right here. And lastly, we have 1 times 4, which will give us 4, which is this last term that we want right here. So this is our final answer. I know that's a lot to take in, but does that sort of make sense? You just have to walk yourself through the process and then think of all the different factors. That's the most important part, I think, is thinking of the factors of the first term right here and the last term as well. Do you have any questions or any clarifications that you want me to go over? Any big concepts, Kyle?
Sorry, Lynn, after this, can I just show you guys a different method of solving this too, just so that Kyle has different methods. So this is actually the method that I use to learn factoring, but last session, we were able to come up with a different, also like a kind of simplified, but not so easy method, but then it works really great. It's actually kind of confusing at first, but if you get the hang of it, it actually works out. So let me just get a new page, and then, sorry, I don't have my keyboard with me, but it's 6z squared plus 11z, right? Oops, sorry. Plus 4.
Yes.
Okay, so the method that we used last time, it's called the X method. Have you guys used it before? Kyle, have you used it before?
I have not used this before.
Okay, good. So we can learn something because I learned this from Josh last time. So yeah. So what happens is what you put under this box right here, you would put your kind of like the variable. So you always want to start with the top box. So your top box is always your let's see, your top box is always A times C. So in this case, it's 24, right? Because it's 6 times 4. And on the bottom, it's always your B value. So in this case, it's 11. So then similarly, you would think of two numbers. When you add them together, it would equal 11. And then if you multiply them, it should equal 24. So any guesses? Okay, so let's see. If you were to add them together, it would equal the bottom number, which is positive. Let me just check the original problem again. Oh, okay, so in this method, what you do is so this is the original problem, right? At the top. And then, do you know which one are your A values, B values, and C values? Okay, good. So the first thing that you do is you always have an AC or A times C at the top, which would be which would be 6 times 4, which is equals to 24. And then you also have to take account also like if it's negative or positive. So then from there, because both of these in the original problem are both positive numbers, it's kind of like, okay, you're good with it, you just multiply it as it is. And then in the bottom number right here, you would go with the B value. So does that make sense so far? Okay, so from there, we're actually looking at two numbers. When you add them together, it's very similar to what Lynn was teaching earlier. We are looking for two numbers that when you add them together, it equals the bottom number. So it's these two. I'll change the color real quick just so that, like, I know it gets really complicated when you first learn it, but it works. I don't know how, but it works. So when you add those two purple numbers, it should equal 11. But when you multiply them, it should equal 24. So let me think this through real quick. Sorry. Okay, so I guess the first thing that we can do, right? What are the factors of 24? good. So I'll just type that here. You have 1. Okay, sorry. I don't know why it's not typing. Okay, 1. We have 2. We also have 4, 6, 4, 6, 12, and then 24. But I know I forgot something. I forgot the 3 and 8. So I'll just go back and put it here. 3 and also 8 goes here, right? Okay, so among all the factors of 24, do you guys see anything that if you were to add them up together, it would equal 11? Okay, good. So you guys got it. So yes, 3 and 8. So then when you have 3 and 8 here, right? So it equals the bottom number when they're being added. Let me just type that here. And then it equals the top part when they're being multiplied. Okay. So from there, the next step that you do is you take the A value, which is 6, right? And you divide both of them by 6. So both 3 and 8 by 6. So from there, divide it by 6, divide it by 6. So if we were to reduce that, the 3 over 6, that equals 1/2. And then how do we reduce 8 over 6? What do they both have in common? 2. Good. So this would be 4 over 3. So then just remember, you will work with the number in which they're reduced, right? The lowest or the most simplified answer. So in this case, we're dealing with the 1/2 and the 3/4. And now this is kind of like where the trick happens. So then what you see in the denominator is actually attached to the x's. So it becomes 2x plus 1. So that's one of the parentheses. And then the other part of it is 3x plus 4. Sorry for my terrible handwriting. But yeah, so from there, that's actually how you would get the factored version. So there's two ways. The way that Lynn was teaching you, Kyle, is how I learned it myself. But if this method works, Lynn, when you're tutoring in the tutoring room, and then Kyle, when you're doing a test, whichever one you feel most comfortable, they actually both work, right? And if you look at the answer that you both got earlier, they're actually identical with each other. So that's just another method that we can all keep in mind. I know I had the same exact expression too. I was like, because you can also use this for a regular factoring, but I mean, whichever one. I think the main thing to remember when you're factoring is that you need to practice, whether it's this method or the method that Lynn taught you in the previous one. It comes with practice. So if you like this method better, I think it's because when you're working with complex A, right? Because A is not always going to be 1. This might be faster. But yeah, if you have any questions, please let us know. Um, Lynn's usually working in the tutoring room, sometimes Sunday, Monday, Tuesday. And then Josh is also working in the later half of the week. Like, I think he's working Monday also, but he's also on Thursday, Friday. So yeah, if you have any questions, please visit our tutoring room. Do you have any other comments, Lynn, that you would like to add? Okay, sounds good. So I guess with that, these are the additional problems that we came up with you. We came up for the students, also for you, Kyle. Please feel free to, I guess, work on them. I can also send you the clickable link. I'm not sure if you're able to click on them directly from the slides. No. So I'll just email you those shortly. Go ahead and factor and practice them. If you have any questions, let us know. Also visit our tutoring room. it's a really good time to come in during the summer because we're not very busy. So then if you like, you can go and work on the problems. I think factoring is where students usually get stuck in algebra, but these are the other resources as well. And of course, our next webinar, you can always come in and ask questions too. So thank you for coming, and yeah, thank you for being a great student like what Lynn said.